Come on in and don't be late. Let's learn science with Mr. Ed U Cate.
Okay, I'm going to have a little competition with myself to see how quickly I can draw the structural formula for butane. Okay, see how I go. I've got my stopwatch here on my huge iPad. Here we go. On your mark, get set, go. Trial 1. Let's see how quickly I can go. Whoa, those H's are slowing me down. And stop. There we go. Structural formula for butane. Took me 15.11 seconds. All right. Think I can get better than that? I think I can. Let's see if I can break that record, that personal best. Okay, I'll just think about it. Okay, here we go. On your marks, get set, go. And stop. Hey, 2.69 seconds, that's a little quicker. And I drew the structural formula for butane. There we go, right there, the one below it. Check it out. What do you think? A lot quicker, a lot easier. We're looking at section 9.3 in this video, structural formulas. So what is a structural formula? Let's have a look at this definition in the left-hand part of the column. It's a representation of an organic compound used to inform the arrangement and bonding of atoms. So for example, ethene in figure 1 here. Ethene's got 2 carbons double bonded to each other, and each carbon is single bonded to a couple of hydrogen atoms at both ends of the molecule. And so you're wondering why they've chosen this particular angle, drawing the bond between carbon and hydrogen out this way, the 120-degree angle. The reason is, that's the way it is. So a structural formula gives a better idea of how the bonds are arranged in a given molecule and which atoms are participating in that molecule. So we're working from page 232 in your textbook, and I just wanted to show you that molecule that I was trying to draw at the very start. This is the butane molecule. So pretty much this is the structural formula for butane. It's right there. It's got 4 carbons that I was trying to draw at the start. It's got its 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. It's an alkane because there are only single bonds there. That's a structural formula. Okay, that's all well and good if you've got a molymod kit like this. But what if you don't have a molymod kit and you wanted to show the formula for butane? Well, organic molecules can be represented in a variety of ways, including empirical formulae. The empirical formula for butane is C2H5. Simple as that. I know that there are not 2 carbons and 5 hydrogens here, but that's the lowest ratio of each element in this molecule. For every 2 carbons, there are 5 hydrogens. That's the empirical formula. What about the molecular formula? Molecular formula for butane is C4H10. That was a weird R there. Well, that's pretty much what there is in the butane molecule. There are 4 carbons and 10 hydrogens, just like that one. But as you can see, if I showed someone that molecular formula, it shows nothing of how this compound is arranged, the elements are arranged, the atoms are arranged, and the bond arrangement in this particular molecule. So introduce structural formulae. Structural formulae or formulas are used to show the arrangement of atoms in the molecule and or the bonding between them. So that's what we're going to look at today. Okay, if you've got limited time and you only want to know the bare basics of this section 9.3, let's do that now. So let's look at 3 ways to draw structural formulae, and we're going to look at the butane molecule. So for the butane molecule, there's 3 ways to depict that molecule. The first way is the extended structural formula. And that way is the way that we've been drawing molecules generally up until now. It's basically like that. You know how it goes. Okay, that's butane. 4 carbons, 10 hydrogens, your little ripper. The condensed, there's the second way of drawing structural formula is the condensed structural formula. So the condensed structural formula for this one, for butane, is writing it like this. That's the condensed structural formula for butane. It's still true. Carbon attached to 3 hydrogens. There we go. Carbon attached to 1, 2, 3 hydrogens. The second carbon in the main chain is attached to 2 hydrogens. That's this one here. 2 hydrogens, 1, 2. And the third carbon to 2 hydrogens. Yep, that's true. And the fourth carbon to 3 hydrogens. Yep. So that's the condensed structural formula. For obvious reasons, it's a lot more condensed. The differences, there's no line showing, no bond line showing. And the third way is a line structural formula. And the line structural formula, just like I showed at the very start, this is how I managed to break my personal best by about 13 seconds. 1, 2, 3, basically like that. That's the line formula for butane. Can you see why it's drawn in a zigzag pattern? Because the real molecule has its carbons arranged in a zigzag pattern. And can you see why there are 1, 2, 3 lines? 3 lines when there's actually 4 carbons. Well, at the end of each line, or at the elbow of between one line and the next, is a carbon. 1 carbon, 2 carbons, 3 carbons, 4 carbons. So in a nutshell, that's our 3 ways of writing structural formulae. 1, 2, 3. So let's have a detailed look at each type of structural formula. In the extended structural formula, it provides lots of information both about the arrangement of bonding in an organic molecule and what types of atoms are in the molecule. And there's, as you can see, there's no ambiguity there. They show everything. The molecule represented so far throughout this chapter has been extended structural formulas. Single bonds are represented using a single line, any double bonds using a double line, triple bonds a triple line. And not only that, the bonds are drawn at the correct angle of, well, to a limited extent anyway. If the angle of the bond is in fact like this, 90 degrees, it'll be shown as 90 degrees. In the case of ethene from before, in the case of ethene, extended structural formula is as so. And so the bond, you actually try to show the bond angle between the carbons and the hydrogens as 120 degrees, and this one is as well. And so it's the one that we use to properly show the structure for. It's probably the true structural formula in my opinion. The second structural formula type is the condensed structural formula, and this is the condensed structural formula for butane. The condensed structural formula provides information about the carbon arrangements in the molecule, but they don't show the bonding that takes place between each of the atoms. So if the formula does not include enough atoms to account for the octets, it's probably because the compound contains double or single bonds. There's only single bonds here, so each carbon has enough hydrogens beside it to show what it's bonded to. If we take the case of ethene, this is the extended structural formula for ethene, this one, and this is the condensed structural formula. So as you can see in this condensed structural formula here for ethene, it doesn't have enough atoms to account for all of the octets. Don't forget that every carbon has got to have 4 sticks going away from it. Okay, each stick, each bond is, remember, 2 electrons each, making up two lots of 4, making up 8 electrons, the octet. But in this condensed structural formula for ethene, there's only 2 hydrogens for each carbon. There needs to be 1 more. Normally we would have 3 hydrogens for a terminal carbon, and this carbon attached to the next carbon, making up our 4. But in this case is not, so we can only assume that there's a double or triple bond there, and of course it's a double bond. But also we can, if we go back to the condensed structural formula for butane again, if there is any repeating units in the molecule, like these 2 CH2s, we can condense it even further. We can write it down like this. There are 2 CH2s in the middle. I'll just rewrite the whole thing again. So there's 2 CH2s in the middle. Rather than writing them out twice, just put brackets around one of them and put a subscript 2. When you condense structural formulas even more like this, by adding brackets, it's a good idea to keep the ends the same. There's another couple of examples in the textbook here. Have a read. They give an example of 2-methylbutane. What about the third type of structural formula, the line structural formula? And this is on page 232 as well. As you can see, this is an example of a line structural formula. It's called the line structural formula for obvious reasons. It's just zigzag lines. This type of structure formula provides information about the bonding, shows you all the bonds, and they show some of the atoms present. I know we haven't written a C here, but it's generally assumed that at the corners and ends of every line here is a carbon. So we know there's carbons there, and we know that there's hydrogens coming off those carbons. And the reason why it's a zigzag is for obvious reasons. This is butane, like I drew at the start. And so, there we go, look at that, superimposed perfectly. It zigzags because the actual molecule has its carbons in a zigzag shape as well. And so the carbons are not written in the representation, but as I said, but at the corners and ends. Hydrogens are not written in, except in the case of any, functional groups. For example, you might have a hydroxyl functional group there, or you might have a carbonyl group there. There you go, it's no longer butane. Sorry, I stuffed it right up there, but it's the quickest and easiest structural formula to draw up, and generally assume that hydrogen atoms are present to complete the octets of the other atoms in the molecule. Don't forget the octet rule. In the case of carbon, there must be 4 sticks, 4 lines coming out from each carbon. Excuse me if I interchange between the word formula or formulae. I've been brought up to use that as the plural for formula, formulae, but looks like the textbook's using formulas. But anyway, so that's why I'll interchange. Let's answer this question. We're going to draw the extended, condensed and line structural formula for butanal. So here's butanal. It starts with butane, so it's got 4 carbons. It ends with al. It's got a suffix al, and when the suffix is al, it indicates an aldehyde, or an alkanal is the IUPAC term. An aldehyde has a terminal carbonyl group, CO double bonded. Terminal carbonyl group, a carbonyl group that's located on a terminal carbon at the end of the main chain. So that's the molymod version. Let's have a go at drawing first of all, the extended structural formula would be, you can start by drawing your main chain, adding all of your outside atoms. There you go, that's the extended one. Here's our carbonyl group, and yeah, double check all the carbons obey the octet rule. 1, 2, 3, 4. Yep, and all the others have 4 sticks coming out. Well, what about the condensed structural formula? Okay, so that'll be just CH3, CH2, CH2, and COH. There we go. And what about the line formula? Well, like the start, 1, 2, 3 zigzags, and the carbonyl group at the end. That's pretty much how it is, isn't it? Remember, the line structure formula assumes that you can piece together all the other atoms in this molecule, yeah, and to obey the octet rule. So there you go. There's another few examples here in worked example 9.3 on page 233. They show the extended, condensed and line structural formulae for propane, butane-2-one, which is an alkanone, which is a ketone, and this really complicated looking one, 3-methyl-oct-3-anoic acid. There's the extended, condensed and line formula. Get your head around that, have a read, and don't forget to do your check your learnings, 9.3. By the way, all of the answers for these check your learnings are all uploaded there on OneDrive in the right folder. Well, I hope you enjoyed that video. Make sure you do lots of practice questions. See you next time. See you next week.